In Lesson 4.7, you'll be identifying similar polygons and also finding the missing measures of similar polygons. Most of you have probably already worked with similar figures in the past, and you probably thought of similar figures as two figures that are the same shape but a different size, but that really is sort of an elementary definition, because I could make two triangles that are different sizes but not similar, or two rectangles that are not similar. In order to be similar, their corresponding angles are congruent or the same size. Corresponding meaning the ones in the same position, like this one right here is corresponding with this one right here. And also the measures of their corresponding sides are proportional. In other words, they have the same ratio when you match up their corresponding sides. This right here is how you will see a congruence statement written. This is triangle ABC is similar to triangle XYZ. Basically, by writing the congruence statement like this, A matches up with X. See this? A matches up with X, and B matches up with Y, B matches up with Y, and C matches up with Z. You can also tell what matches what by these arcs that are drawn in the angles. The one with one single arc is congruent to the one with one single arc in the other triangle. Also, the sides are in proportion to one another. So this side compared to this one is the same ratio as this one compared to this one, and so on. If you write ratios matching up the sides, you're going to have the same ratio. So example 1 says determine whether rectangle HJKL is similar to rectangle MNPQ and explain. Well, when you match up your corresponding sides, like HJ, this one right here, is going to match up with MN. If I'm matching the small one to the big one, I need to make sure I'm doing that with all of my ratios. So I'm going to write 7/10. And the other side measurement I have is right here, HL. HL, that's going to be the same as MQ. MQ is right here. MQ is 6. So since I went small to big for my first two, I'm going to go small to big here. 7/10 is not equal to 3/6. Since those are not equivalent, these are not similar. They do have angles that are congruent since all the angles are 90 degrees, but because the sides do not have an equivalent ratio, they're not proportional to one another, therefore they're not similar. One is a little more stretched out than the other. Kind of reminds me a little bit about clip art. Like if you have a piece of clip art, if you click on one of the sides and drag it, you're going to end up with something that's a little distorted looking, where if you click on the corner and drag it, it's going to get wider and longer at the same rate. So it's going to still look right. It's not going to be out of proportion. All right, you may want to pause the video and try the next two on your own. We're looking to see if these two polygons are similar. So I'm going to take the short side of the rectangle and match it up with the short side of the other rectangle. And then I'm going to take the long side of the rectangle and match it up with the long side of the other one. Keep in mind that we went from big to small both times here. Now 6/1.5, that's 6 divided by 1.5, which is 4. And then 14 divided by 3.5, that is also 4, which makes those two ratios equivalent. Since the ratios matching up the corresponding sides are equal, the two figures are similar. Got one more to try here. The shorter side of the triangle 6 matches up with the shorter side in the other triangle, which is 8. And then the longest side of the small one is 8, and the longest side of the big one is 12. 6/8 is the same thing as 3/4 or 0.75. And 8/12 is the same thing as 2/3 or 0.6 repeating. Since those two ratios are not equal, these two triangles are not similar. The next thing we're going to do is find the missing measurement in two similar figures. So we're not trying to prove that they are similar. We know they're similar. We're going to just try and find the missing measurement. The ratio of the lengths of two corresponding sides of two similar polygons is called the scale factor, and you can use the scale factor of similar figures or a proportion to find missing sides. I'm going to go ahead and solve these problems using a proportion. Later in this chapter, you'll learn more about scale factors when we talk about scale models and drawings. So in example 2, it says, given that polygon WXYZ is similar to polygon ABCD, find the missing measure. What I always do is start with what I don't know. I don't know this side right here. So I'm going to write a proportion matching up M with its corresponding side in the other figure. M is between X and Y, or it's the side XY. XY is going to be the same as BC in the other one. I can also tell that by looking at these angle marks. It's between the 2 arc and 3 arc, 2 arc and 3 arc. So this matches up with this. So M over 12. If they're similar, they're going to have equal ratios. So I'm going to put an equal sign, and now I'm going to pick one of the other sides where I know both the measurements. I'm going to go ahead and pick this one right here. This is important that you pick the same figure to start with in both ratios. That's why I draw the circles around and arrows pointing to where it matches. Your arrows have to both be going in the same direction. So 15 matches up with 10. Now you have a proportion just like you had in the last lesson. The cross products in a proportion are equal. M times 10 is 10M. And then 12 times 15. 12 times 15 is 180. Now to solve this equation, instead of multiplying by 10, you would divide by 10. And when you take 180 and divide by 10, you just move the decimal one place to the left, which means that side length, the missing measurement, is 18. You may want to pause the video and try the next one on your own. I'm going to go ahead and fill in the 18 that we already found right here. Now the next one we want is WZ. WZ is this side right here. This one, I'm going to just call it X, matches up with this side over here. So X matches up with 13. And then pick one of the other sides. I'm going to just go ahead and use 15 and 10 again. Remember to make your arrows going in the same direction. Now to solve this proportion, X times 10 is 10X. And then 13 times 15 is 195. To solve this for X, you would divide both sides by 10. You get X equals 19.5. And now for AB. AB is this one right here. I'm going to call that Y. Y matches up with this side right here. So I'm going to say Y over 24 equals, pick another side. I really like this one here, so I'm going to go with 10 matches up with 15. Now, in a proportion, cross products are equal. So Y times 15 is 15Y. And 24 times 10 is 240. Now you're going to go ahead and divide both sides by 15. 240 divided by 15, that's going to be 16. All right, the very last example has to do with perimeter. If two figures are similar, their perimeters are proportional as well. So it says triangle LMN is similar to triangle PQR. If the perimeter of LMN is 64, what's the perimeter of PQR? Well, I'm going to go ahead and write a proportion. 24 is going to match up with 18. So 24 over 18. And then I'm going to take the perimeter of the large triangle. The perimeter of the large triangle is 64. That's going to be over the perimeter of the small one, which we don't know, so I'm going to call that x. Then we go ahead and solve it. 24 times x is 24x. And then 18 times 64. 18 times 64 is 1,152. Then divide both sides by 24. And you get 48. And since we're talking about units here, it's going to be 48 units, which is choice C. You may want to pause the video and try the next one on your own. Square KLMN is similar to square TUVW. If the perimeter of KLMN is 32, what's the perimeter of TUVW? Well, 8 matches up with 16. And then the perimeter of the small one is 32. And that matches up with the perimeter of the large one, which we don't know. So we have 8 times x, which is 8x, equals 16 times 32. 16 times 32 is 512. Divide both sides by 8. And you get x equals 64. 64 units is the answer.